Thank you, Jennifer. Okay. Well, thank you all for having me here today. Thank you for joining us here at the DSA Global Summit. Very excited about our agenda here, and we've got lots to discuss. So today, we've got about 20 billion connected devices. We estimate that there's going to be a growth of at least 5x by 2030. And what's emerging is an internet of intelligent things. Data. About 500 million terabytes of data is created every single day. Just a small fraction of that actually is connected to the network and goes over the internet. The vast majority of that is accessed using license-exempt technologies like Wi-Fi and Bluetooth. Our challenge really, at the end of the day, is connecting everyone. How do we do this in a cost-effective way, given variety of terrain and, economics? Well, Broadcom sees the importance of all technologies in order to connect the unconnected. And so we see Wi-Fi and cellular really helping to bridge this digital divide together. But what about some of these places where we don't have fiber or we don't have wireless, fixed wireless access? There are gaps in coverage there, and it's been very, very difficult to economically cover that. So we see NTN technologies really rising up in the WRC 27 time frame and in the 2030 time frame, where we're going to be using these types of networks to really cover those areas that cellular and Wi-Fi can't quite cover. But there's an issue. The economics of cellular is just incredibly difficult. It adds about $100 US dollars to add on a cellular radio when you're talking about portable electronics devices. How do you connect those things that only cost $15, $20, $30? And we have this intelligent Internet of Things that it's arising. So it's about 5 to 7 times more expensive than Wi-Fi in an end user device. When you start talking about infrastructure, it's way more expensive than that. And there's a lot of complexity in implementation. When you're implementing a cellular device, it's got to be certified to each cellular network operator. You don't have, like the Wi-Fi Alliance global certification body that makes sure that something that's made in China connects to something that's made in South Africa. So you need to have boots on the ground in every one of these countries, making sure that what you've developed actually will work in that country's network. We do expect at Broadcom to these same economics to apply to cellular NTN technologies. So just going to put a pin in that point right now, and we'll cover that later. So absent smartphones and cars, most devices do not even contain cellular connectivity. Wi-Fi, on the other hand, is in nearly every single device. There's a 6 times higher attach rate. If we were to just remove smartphones from the equation, 6 times more devices have Wi-Fi connectivity than cellular. So if we need to connect the unconnected and we're looking at all kinds of different devices, we need to be thinking about the radio that's going into that device. Wi-Fi remains the backbone of everyday connectivity. It continues to be the world's on-ramp to the internet, and over half of the world connects primarily through Wi-Fi networks. It extends wired, but fixed wireless. There's a lot of discussion about fixed wireless. Fixed wireless networks still need to use Wi-Fi to connect to the end user devices. And then as satellite broadband really kicks off, it's Wi-Fi that's providing that last hop. It's versatile. I see Paul here, Colmer from South Africa, and Paul talks quite a bit about how Wi-Fi or Wi-Fi-like technologies are using for, tens of kilometers of coverage. We're enabling smart devices. So hopefully we'll have Alan Norman from Meta talking later, talking about some of the innovations that Meta's doing right now to use that last hop from your glasses to your compute device. And it's evolving. The ultra high reliability that we have today is really predicated on access to the 6 gigahertz band. 6 gigahertz is foundational for Wi-Fi 7. Wi-Fi 7 was built from the ground up, and these are the devices that are deploying in today's marketplace using the 6 gigahertz band. Wider bandwidth, 320 megahertz channels. Those 320 megahertz channels can't be done in the 2.4 gigahertz band or in the 5 gigahertz band. You have to have access to the 6 gigahertz band for them. 496 QAM. That's incredibly difficult to achieve on a signal to noise ratio. The 6 gigahertz band is incredibly quiet indoors. So it makes it a lot easier to hit the code rate so that you can have much better throughput. Multi-link operation brings cellular-like connectivity where we can bond the 6 gigahertz band, the 5 gigahertz band, the 2.4 gigahertz band, so that we can move traffic the most intelligent way. And then finally, we can really boost power using the automated frequency coordination. So all of these features really are brought to life in Wi-Fi 7 because of the 6 gigahertz band. What does that get you? Well, we get about 5 times more capacity with Wi-Fi 7 than we did Wi-Fi 6E. The latency, 100 times lower in worst case latency, so much higher reliability. Determinism, when we're talking about these AR, VR, AI use cases, about 15 times better with Wi-Fi 7 and 6 gigahertz. And coverage, with automated frequency coordination, we can achieve 63 times higher transmit power than we can with low power indoor. So how is it being deployed? Well, I like to talk a little bit about Comcast. They're the world's largest converged operator today. They've got about 32 million subscribers, probably a little over 8 million now mobile lines, and 23 million hotspots. They estimate that over 90% of the data on their smartphone goes over Wi-Fi, okay? 94% of the devices that are connected on their networks with their subscribers are over Wi-Fi. And here's the staggering number. I just recently bought a home and connected it. I probably got about 50 or 60 connected devices. But at Comcast, they're saying their top 1% of their customers have 150 connected devices. I don't even know how that's possible, what they're connecting. But that's what they have on their network. So that's the tip of the spear. They're doing that with an intelligent AI connection manager. So now we're at the advent of the AI age. What does that look like? Well, today's mobile networks are geared for downlink. So it's about 90% downlink and 10% uplink. And that makes sense because streaming video drives the internet. And that's about 97% downlink. But when we talk about next generation use cases, why is streaming video a next generation use case? It's not. It's going to remain the bulk of the internet traffic for the foreseeable future. But if we need different things in order to bring in new capabilities, we need to be focused on the uplink. Without a reliable uplink, you are not going to bring about next generation traffic. What Broadcom sees, when we talk about AI, we talk about reliability. Reliability, especially in the uplink. So whether we're talking cellular, satellite, Wi-Fi, Bluetooth, fiber, it doesn't matter. Pick your connectivity. At the end of the day, you need to have an incredibly robust uplink to engage with AI that's doing the computation and then responding to your prompt, context aware. You need 2 times better voice latency than today's voice in order to bring about the next generation in AI. So imagine Iron Man, the movie, Jarvis. We expect to see Jarvis-like AI voice in the 27 timeframe. The AI data centers are well capable of that. We have the fiber build out, but you have to have incredibly low latency on the uplink. We're only talking about 100 kilobits of traffic, so we're not talking about massive reams of traffic here. But what we're talking about is incredible reliability so that our buffer is only about 5 milliseconds in order to be able to have that barge in, barge out, where AI isn't still computing something that you've asked 5 seconds ago, but it's very agile, working with you, conversational. It's going to require 10 times greater reliability. So Broadcom in October introduced a full ecosystem of Wi-Fi 8. And the way that we were looking about this as an organization is, what do we need to do to bring about these services that we already see? This isn't a moonshot. This is stuff that's here today, but it needs to be fully enabled. And we see Wi-Fi 8 platforms doing that. So with Wi-Fi 8, you don't have a couple of anchor features. It's not like just MLO or 320 megahertz channels. It's a variety of features that we've put together that will address issues that users have on a daily basis. People aren't sitting right next to their access point consuming video or engaged in a Skype call. They could be roaming anywhere. So what Wi-Fi 8 did is it really addressed pain points that users have to increase throughput, extend the range, increase capacity, and improve reliability and quality of service for every single connection. We just talked about all of the advancements in Wi-Fi 7. Wi-Fi 8 delivers so far beyond Wi-Fi 7 with that collection of features. We can now deliver a 200% higher median throughput. So I'm not talking about the edge or best case. I'm saying typical throughput that a user would have with any device is going to be double. The latency, when we talk about P99, at the end of the day, if we're measuring latency in 5 millisecond bits, we care about the 99th percentile, not the 50th percentile. Otherwise you're going to have lags every 3 or 4 seconds. So we care about kind of the totality of that transmission. With Wi-Fi 8, you're going to have much better, much higher reliability uplink voice latency. Power is the new arbiter of everything. When we think about AI data centers, when people talk about these big deals, they're not talking about it in dollars, they're talking about it in gigawatts. Power is everything. And if we're going to have all of these intelligent connected devices, we need to figure out how we can do this at an extremely low power rate. Wi-Fi 8 delivers for these IoT devices a 50% reduction in power consumption. This is pain points that users feel all the time. No one wants to go out and put a new battery in for their doorbell or their camera every couple of months. So this greatly extends that range. And then finally, 2 times better IoT coverage in a line of sight scenario. So you're going to be talking about being able to provide whole premises coverage for all of your connected smart things. Access to unlicensed spectrum is the key. So even though Wi-Fi 8 is not certified yet, the standard is not done, chip makers like Broadcom fuel the ecosystem. We're providing it to our partners who can then take these platforms, build upon them, and launch them into the market. But we've already built our Wi-Fi 8 chipsets. So what are we doing? We're working on Wi-Fi 9. And we're working on the collection of features that we see right now. We'll begin working with collaborators in the IEEE before long. And we're going to be looking at what is not addressed. What's not addressed with the NTN cellular technologies? What's not addressed in peer-to-peer? What do we need to do for dense enterprise use cases? How do we bring all of this together in a network of intelligent things in the 6G umbrella? And I can tell you that we're going to be relying on regulators. We understand these debates as it relates to the 5 gigahertz band or the 6 gigahertz band or the 4 gigahertz band. Spectrum is a finite resource. But we encourage you, when you're looking at allocating spectrum for mobile use cases, let's allocate the right thing. At the end of the day, we shouldn't be allocating spectrum just because we want to be able to build the next bit or bob. We need to be looking at, how do we fuel this uplink? How do we provide data in these hard to reach places, and what spectrum is going to be required for that? And so for Wi-Fi, it's very important that it fits within the span of a radio. So if not 6 gigahertz in the upper band, as some of the regulators have decided to allocate that for IMT, I would just challenge you with where. Because at the end of the day, Wi-Fi is going to continue to be the workhorse, and Bluetooth is moving into every single one of the Wi-Fi bands. Bluetooth is going to be there as well. And so these devices coexist. There's coexistence with ultra-wideband. To an extent, we continue to work on that. But we've got to figure out how we're going to coexist with cellular, how are we going to operate in places that cellular's not operating, and how are we going to connect these satellites? Could we have a standard where Wi-Fi is beamed down directly from a satellite? Well, stay tuned. But greatly appreciate the opportunity for you all to join us today, and happy to take any questions that you might have.